Hello, everyone. DJ Kalicha Kid here. Thanks for tuning in to RGV Community Health Hour. Just a quick reminder, the views expressed on RGV Community Health Hour are for informational purposes only. Oh, um, and and do not constitute medical advice. Be sure to consult your primary care provider for all your healthcare needs. On today's show, I have a returning guest that hasn't been on the show since I first started it about a year ago. So today I have PhD candidate Marco Arriaga um, here to talk about what he's been up to in the last year. So Marco, thanks for coming on the show.
Hi everyone. Good morning. Thank you for having me once again.
Yeah, of course.
Yeah, it's been quite a ride in this last year and a half, working on a PhD on genetics, right? A lot has been happening, but for the most part, just been trying to step forward and do what we need to do in order to graduate and finally be more independent scientists, right?
hmm Yeah, I think a good way to start this conversation today would be for you to talk a little bit about the fellowship, right? You got a fellowship? Is that what it's
Yeah,
considered?
yeah, it was a fellowship. Are you talking about the Exposomics one?
Yeah.
Yeah. Well, it was more like I guess a short fellowship. Yeah, it was more like a training fellowship
Mm.
kind of thing. Yeah, so I applied and was awarded with this fellowship to go to New York in Columbia University,
Nice.
where we basically train and basically share insights on developing methods for exposomics analysis. So, for those of you that are not too sure what exposomics are, basically we're trying to identify or detect every type of environmental toxin or synthetic toxins that anyone can at some point in their life be exposed to. So compared to other types of similar assays, normally when we try to see there's like some type of exposure to a specific toxin or pollutant, we normally just try to look at one thing at a time, right? With this work on exposomics, we try to detect as much as we can, and we can try to make different types of insights in terms of like what are the exposures that have been affecting an individual, and if somehow these exposures have any type of relationship with a disease that this individual may develop
hmm
or has been developed over time, right? So yeah, that was a pretty interesting way, and um, many people when they think of exposomics, they think of like chemistry heavy, kind of like techniques and things like that. But in reality, with a lot of which is chemistry based, LCMS or liquid chromatography, mass spectrometry, combination of chemistry, physics, and also biology, obviously. But the training work was more than in order for us to be able to analyze this data and see how we can make associations with disease.
Yeah, well, thanks for that brief kind of explanation because, obviously a lot of the listeners may not have that scientific background. So, um, a question about that and something I've been thinking about a little bit lately. So, we know, like for your project, for example, you're looking at aflatoxin, which is a mycotoxin made by mold.
Hmm.
Um, And so you're looking for the certain metabolites. Well, I guess like okay, not even considering your project and the specific toxin itself. I mean, we're just exposed to so much every day, whether it's tainted water, bad air we breathe, bad food, and that's potentially where aflatoxin we get the most exposure from our food supply. So it's kind of hard to pinpoint exactly. Like you can have some kind of, we'll just use fatty liver, non-alcoholic fatty liver as an example, because that goes hand in hand with the aflatoxin.
Hmm.
So you can look at, well, I guess you can look at somebody's disease state. You know, they have NAFLD, non-alcoholic fatty liver disease, and then you can look, you know, based on your project, you're looking at their serum to see what their levels are of that, um, I guess, metabolite in their serum or blood. Um, but it's like for me, it's so multidimensional and multifaceted. It's like, okay, even if they have high levels of, and I guess it's about painting a bigger picture, right? So even if they have high levels of aflatoxin metabolites in their serum, and they do have non-alcoholic fatty liver, um, I mean, it's correlation, right? But it's not always causation. So
Yes.
you want to speak a little bit about that in terms of like, hey, it could also be, I don't know, terrible, you know, some kind of other terrible exposure.
Yes. As you know, but maybe part of your audience is not too knowledgeable about this, but fatty liver disease, whether it's alcoholic or non-alcoholic, and other complex diseases, that's what they are. They're complex diseases, and the reason why they're complex is because there's different things that can induce the development of these diseases in the body, right? Here, what we're trying to do, we're just trying to pinpoint if, in this case, this toxin, aflatoxin, contributes to the development of it.
Mm-hmm.
Like you said, it might not be the main cause,
Mm-hmm.
but the fact that it's contributing to it, we can still consider it as part of the cause of it, right? It
Mm-hmm.
may not be 100% attributed to it, but being able to pinpoint one part of it is a big advancement into developing new methods to treat this type of diseases, right?
Mm-hmm.
So, talking specifically about this complex disease, NAFLD or non-alcoholic fatty liver disease, um, most of the times, like the treatment comes down to what it's kind of like the general thing for everything else, which is having a good diet, exercising, right?
Mm-hmm.
Like having a more basically healthy lifestyle, right? And that should help. That should help,
Yeah.
right? But in most cases, when people are very susceptible to this type of like um, exposures, then people have a disadvantage, right?
Yeah.
So there's still very important for us to see and pinpoint what are the causes and try to see how we can, um, I guess, deal with these causes. But step number one is understanding the disease,
Mm-hmm.
right? Step number two is understanding what develops the disease. And then step three, you can attack those sites where, okay, if we know this is happening and it results in the disease, then we can make some interventions at that point to avoid the disease from developing, right, on
Mm-hmm.
this individual.
Mm-hmm.
So, yeah, so complex diseases are now something that is that involves other diseases like, for example, cancer, right? Like one of the most um, big diseases that take a toll in a lot of people, right, around the
Mm-hmm.
U.S. and around the world, really. But these are diseases that, like you said, multifaceted because there's different factors that eventually result in this disease phenotype, right?
Mm-hmm. And so, and I know because you know, we share an office and we're classmates. I know that you're going to do 1,000 samples from our MAFS cohort. That's from the MAFS,
Yeah.
the Mexican American Family Study. And I was wondering, are you doing so many samples for that statistical power in terms of like, okay, if you did 100 samples, like if you did 10% of what you're planning on doing, you might get hits in terms of like, okay, this person was diagnosed with NAFLD and they have high levels of aflatoxin metabolite, but you can't know for certain whether it's correlated until you
Yeah.
get like, you know, that high.
Yeah. Okay. So yeah, to answer this question, which is an interesting question, first we had to kind of like touch base on what's high levels, right?
Yeah.
Because somebody with high levels of this toxin, honestly, would be dead. So
Yeah, I guess that's true.
you're never gonna find high levels. Like again, to give a little bit more background on the toxicity of this mycotoxin, it actually, when it's present in the body, it actually can also induce hepatocellular carcinoma or liver cancer, right? and the high levels are not so high.
Mm-hmm.
You're talking about
There's like
in
parts per
basic terms,
billions.
yeah, like is in terms of concentration, it's
Mm-hmm.
like in micromolar.
Mm.
If you're finding this at the micromolar or millimolar level, yeah, this person is really really sick, or it might not survive, right?
Mm-hmm.
And this has to be somebody that has been highly exposed to the toxin through food or whatever other route for a long time as well. So there's a really low chance that this individual can survive this, right? But what we're trying to do here, we know that, or yeah, we know that the toxin is out there.
Mm-hmm.
We know that the toxin, like you were saying, like it comes from mold, which is a fungi that secretes this toxin in crops.
Mm-hmm.
Specifically, one of the main ones that is consumed here in our community, corn, right? And as you also know, because we talked about this before, and actually you found this information before me. The way that the contaminated corn is diluted, like
Mm-hmm.
it's maybe not the best way, but that's where the guidelines or the way that the policies right now, that's how they're made up. It's
Mm-hmm.
just diluting the contaminated corn with non-contaminated corn, right?
Yeah.
Which, in terms of what is established right now, it's okay according to the law, but we know that people are still being exposed to it, and even a study done back in the 2000s like show high levels of aflatoxins in the crops around the valley.
Oh wow.
Yeah, so it's been there for quite a long time.
Mm-hmm.
um, and so what I'm going to this is like high levels of aflatoxin um, are not necessarily going to be present, because at the same time, your body, your liver, it's kind of like doing its job, which is one of the organ that is trying to detoxify your blood, right?
Mm-hmm.
To make sure that you don't have any microorganisms or other toxins that can give you a disease, right? But when the exposure to these toxins is too much, then your liver starts getting tired, starts getting non-functional, and that's when the toxin can actually affect you, right? So, in terms of levels of aflatoxins, you're talking about really low levels. You're talking about a low in the micromolar level, and even as low as picomolar level. For those of you that are not sure what picomolar, and when we say pico is one in a billion,
Mm-hmm.
right? Like it's really, really, really low. Um, but this low uh, these low concentrations that are exposed to the people can still induce the development of a disease. So what we're trying
Mm-hmm.
to do here is I'm developing this assay with liquid chromatography mass spectrometry to detect really low levels of this toxin, and I can detect it at even at the picomolar level.
Wow.
And we have seen it in some of the samples, like you said, that I'm working on. Yeah, it's going to be 1,000 samples. Just we need, like you were saying, we need the statistical power, and in order to get that, we need to work with a lot of samples, because the detection that I'm doing is such a small amount,
Mm-hmm.
so we can make any like um, conclusions that, oh, there is a relationship between the toxin and the development of the disease.
Mm-hmm.
Obviously, the individuals that we are working with had also been monitored with their fat content in their liver,
Mm-hmm.
which is the main sign of fatty liver disease. And we did this by a method called, sorry, the word went away, but it's basically they're looking at fibrosis on the liver. So
Mm-hmm.
basically, that accumulation of fat in the liver. Yeah,
Yeah. And so
fiber scan. Yeah,
yeah, yeah, the
sorry.
fiber scan,
Yeah.
yeah. And so that actually, well, actually, I think I'm gonna take a quick music break, and we'll be right back because you led me into one thing I was gonna ask next. So,
Sure.
thanks for staying tuned, everyone. We'll be right back after this short music break. All right, everyone. Thanks for staying tuned in. I am back with Marco Arriaga, PhD candidate in our human genetics PhD program. Okay, so before the music break, we were talking about the number of samples that you have to do for your project and the reasons why. So I was wondering, because I know in terms of what I proposed whenever I was, when we were proposing our projects, our dissertation proposal, I got asked because I was planning on using iPSCs, induced pluripotent stem cells, from our cohort to expose them to my project involves a component of air pollution, and I don't remember. Of course, Dr. John Blangero does the statistical power calculations for us because he is he's a world-renowned statistical geneticist. And I don't remember how many, because this was over a year ago at this point, how many samples he proposed that I should do. And apparently you got stuck with 1,000. So, and so when I got asked, so of course, after we pitch our proposal, we get asked questions. And one of the questions I got asked was, how are you going to select your samples that you're going to use from the biorepository or from our cohort? And I said randomly at first, and that was the right answer. And then I was like, well, maybe. And he's like, no, you got it right the first time, randomly. So that's one thing I was wondering about you. Are you just randomly grabbing samples, or are you taking into account, and this is why I said this is a good stopping point for the music break, was because you had mentioned, like, hey, you need samples where they have essentially been monitoring their liver fat, right? And so is that the only consideration, or are you taking any occupational considerations, any age considerations, or anything like that?
Yeah. So when we're doing this type of work, obviously the more information that we have from the patient, the better, because that way we can also include the covariates for the statistical analysis. So covariates are things that could have some type of weight or on the development, in this case, on the association with the disease. But I am actually kind of like blinded as well. I know we have liver fat measurements, but I don't know what they are.
Yeah.
And it's not good to know right now, because then you become biased about trying to find something because, it has high levels of fat. So I really want to make sure, and I might not find something. It's kind of like you're putting that extra stress on the work that you don't need. And the correct way is always to do it blinded, right?
Yeah.
Blindfolded. So no, everything that is considered is that there are individuals that come from a cohort that are of Mexican Americans, and they're from kind of like the valley, like literally from San Antonio down to the valley.
Yeah.
And the other important part is that these individuals are a part of the family study cohort, right? So in other words, we're not taking just random people. In other words, we're more taking like random families.
Yeah.
So if one individual from a specific family core has fatty liver disease, and then another individual that might be the brother or the sister or the daughter or son, whatever, they might not have it because maybe age difference. That's one thing, right?
Yeah.
But we do know that they've been exposed to a similar level of aflatoxin, then these individuals might come at a higher risk of developing in their future, right? And again, some of these samples have been collected over 30 years.
Yeah.
So, like some people at this point are 30 years older since they got their first blood collection, right? But I mean, other things that we take into account is, like you were saying, gender, age, type 1 diabetes, type 2 diabetes. If they have any other diseases that might be related to fatty liver disease. Obviously, the fat measurements that I was talking about, their waist circumference at the time of the collection, their weight, and all things like that.
Yeah. Because I mean, I don't know too many details about our cohort because I don't really work with any of the samples from the biobank. But I imagine there's like a plethora of information about the people who we do have samples for, right? Like, it's not like we have, we'll just say, we'll round down. We'll say we have 2,000 people in the cohort, and it's not like 1,000 of the people we just have their blood and no other information or their serum. and no other information. I mean, we probably have their serum, maybe some other tissue samples. We'd probably have questionnaires about their lifestyle for sure. So it's like you're not going in completely blind in terms of like, okay, this is this random sample, and all we have is their blood, essentially.
Yeah, no, yeah. So they have, uh, for the most part, what I know, because again, I don't know everything because I only know what I need,
Mm-hmm.
right? But I do know that obviously blood collections where they do separate um, the plasma, the serum, which are two different things, but they're very similar though. The difference is that anticoagulants in one of them. Um,
Mm-hmm.
then they also have basically the white blood cells, right? That's where they eventually use to developing the induced pluripotent stem cells. Um, and they should have other biofluids. I believe they might have urine
Mm-hmm. Yeah, that's what I was
and
thinking.
maybe
Probably
even
urine.
saliva. I'm not sure
Okay.
for all of them, but and if like I said, like I really just need the plasma and the little basically the information about them, like if they have the liver fat measurements and the gender and like things like that. Also, we obviously don't know anything about their personal information, like their
Mm-hmm.
names or things like. We don't
Yeah.
know any of that, but if we wanted to, and if it would be allowed by the IRB, from the university, we could make kind of like a geographical study, right? We could kind of
Mm-hmm.
like get maybe not necessarily the address, but maybe like the zip code on the individual, and try to do some analysis to see like if certain people in certain areas are have a high exposure of the toxin compared to other areas in South Texas, basically.
Yeah, that'd be a really cool thing because I mean, that's one thing I always find the most interesting about. I guess it's like almost epidemiology, right? Like you're
Oh,
trying,
definitely.
yeah, it's like trying to see pockets of sickness in the community. And I think that's like one of the most powerful tools that we have in terms of understanding environmental exposures.
Hmm.
Because when I first started actually researching the aflatoxin, um, I found information about, I think it was liver cancer as well. So the state of Texas did like a liver cancer survey where they just, everybody who had liver cancer was, hopefully, um, what's the word I'm looking for? Volunteering, I guess, their information, and where they lived and stuff. And based on, like we just talked about, like these pockets and concentrations of people with liver cancers in certain areas, then the state sent people out to those areas to investigate the environment and see if they can find any toxin. And in Houston, they found what was it called? The subdivision or the area of Houston. Oh, it's right there on the tip of my tongue. I can't remember. Anyway, the name isn't important. But they found like a pocket of liver cancer in this area of Houston. Cashmere Gardens, I want to say is what it is. I could be wrong about that, but yeah, so they went and investigated, and they found that there was a railroad company who had like I don't know if it'd be considered a manufacturing plant or whatever, but they had the chemical that they dipped the railroad ties or the railroad, the wooden railroad,
Hmm.
you know,
The tracks.
yeah, the tracks, the wood they use for the railroad tracks. Well, they dipped those things in like a terrible chemical to, obviously they want to preserve the wood and don't want bugs to chew them up and rot them out. And that chemical was leaking into the ground, and it ended up, being the cause of what was making a lot of people sick in that area.
Hmm.
And that just blows me away. I think, like I said, it's such a powerful tool to be able to do that. And I know, I've had Dr. Vincent Diego on this show, and he of course talked about his background in it and everything, but I'll never forget taking his class and being shown like like a map, like a physical latitude and longitude map showing like, hey, based on this information we got from these people, they're likely sick in these areas. Like you just talked about, right? You can kind of get like a geographical representation of the sickness, and I think that's really cool because because then you can go and investigate more. Like, hey, maybe go do some surveys in people in terms of their diet, or just look at environmental pollutants, like maybe something terrible got spilled around that area 10 years ago or whatever the case is. But we know, especially for yours, being aflatoxin, we know more than likely it's coming from uh, food,
Yeah.
contaminated food. And is there any other routes of
Exposure.
yeah, routes of exposure for aflatoxin that really makes people sick, or is it mostly just because like with me and the benzoate, it's a component of air pollution, but it's also in your barbecue, so you can ingest it just through eating charred foods,
Yeah.
or you can just breathe it in through air pollution.
No, it's like many things. Yeah, in this case, aflatoxin. Obviously, if you literally have a mold that is secreting these toxins, like there's a chance that you can inhale it as well.
Mm-hmm.
But the most common route it's ingestion. Yeah. So basically, when you eat your food that is contaminated, and it doesn't necessarily have to be crops only. It could also go to uh, foods like if the for example, if a cow is consuming this contaminated corn,
Mm-hmm.
now the cow has been exposed to it, and if we eat the meat or drink the milk from the cow, there's a chance that we can also
Yeah.
be exposed to the toxin, maybe at even lower levels, but again, accumulation.
Mm-hmm.
There's enzymes in your liver that can break down the toxin, but actually, the metabolism of the toxin is the most dangerous part. It's not necessarily the toxin itself at its primary structure. It's like what is metabolized after that becomes like a really strong carcinogen,
Mm-hmm.
and the further metabolism can also, like I said before, like that's kind of like the part that we need to investigate further once we confirm if there is association or not. If there's association with this toxin to the disease, then we can dig in more to see where, like, what mechanisms are
Mm-hmm.
taking part and at the molecular cellular level that is inducing the aggregation of fat and eventually scarring of the liver that does not allow the liver to regenerate, right?
Mm-hmm.
And that
Mm-hmm.
eventually can proceed from steatosis, which is just fat accumulation, to fibrosis, which is scarring of the liver, to literally uh, necropsy of the liver, or cirrhosis, right?
Mm-hmm.
And after that, it could also lead into hepatocellular carcinoma. So finding answers to these questions that we have is not only to avoid fatty liver disease, or at least to not let it develop so easily, but also in the long run, it allows the individuals not to eventually develop diseases like cirrhosis and hepatocellular carcinoma, which is
Mm-hmm.
liver cancer.
And are there any plans to do any kind of genetic investigation, right? Because you can have people who are more genetically predisposed to being sick from it versus, so like say for example, you find two people um, in your samples, right? Two samples in your study, and they have the same level of aflatoxin exposure, right? Same levels in their serum, and one of them has NAFLD and the other one doesn't. Is there any plans to do any kind of genetic investigation to see? I mean, I know it might not be so straightforward,
Yeah,
and
yeah. I
I mean,
mean,
it's like,
those plans are for whoever's coming after me to work on this project. Like,
yeah, it's obviously we don't have that much time
yeah,
left,
we
so.
don't have that much time left, but it would be like it would be a really cool project to work on. And
Yeah, for
yeah,
sure.
I guess I should also mention that the individuals in our cohort are also completely sequenced, and we
Mm-hmm.
also have the genotypes.
Mm-hmm.
So yeah, there's definitely information to do the type of analysis, although it's not as simple as one person with it, one person without.
Yeah, yeah.
You need to have like a group of people that,
Mm-hmm.
again, that is going to offer you that statistical power to really say, like, oh, these genes are being affected by the toxin,
Mm-hmm.
and this is how it induces the fat accumulation in the liver at a abnormal higher rate than normal fat accumulation when somebody is exposed to too much fat, or
Mm-hmm.
you know or we can understand, like, oh, okay, the gene that basically results in this specific enzyme is actually being affected. So then we cannot produce that enzyme. So then the toxin cannot be metabolized, at the, I guess, the physiological way, under normal conditions.
Hmm.
And that's why people are being affected in that way.
Okay. And do you know, one quick question before we take another music break? Do you know so you're going to do 1,000 samples? What percent of the cohort does that represent? I know it's over like 2,500 samples in the cohort,
Yeah.
right? So is it
Well,
like
so
almost
I
half, about a
yeah, no, I
third?
actually I actually had to say too that, it's 1,000 samples, but it's actually from two cohorts.
Oh,
It's
okay.
actually 500 for MAFS, like you were saying, Mexican American Family Studies,
Mm-hmm.
which is people from San Antonio down to the valley, and we also had the RGV Family Studies, which is literally people from the valley as
Oh,
well.
okay.
It's 500 and 500,
Oh, okay,
and
cool.
because the populations are really similar, that's why we're combining it, and
Mm.
again, we can determine if there's the exposure of this toxin in these two populations.
Hmm.
Hmm.
Okay,
But
well,
yeah, oh sorry, I'm sorry. In terms of like total, yeah, I know it's
yeah.
maybe like a fifth.
Yeah, I would say if
Yeah,
it's
because it's
considering
two
two cohorts,
cohorts. Yeah.
yeah. Okay, cool. Well, thank you for that answer, and we'll be right back, everyone. So thanks for staying tuned. All right, everyone. Thanks for staying tuned in, and we're back to keep talking about all kinds of things with Marco Arriaga. So, Marco, I think we got about 10 minutes left or so. I think it'd be good to talk a little bit about our trip to Boston.
Oh yeah.
Yeah. So, yeah, we just got back from Boston over the weekend, or I guess you got back on
Yeah.
Friday. Yeah.
Yeah. Yeah. Pretty
Yeah,
close.
basically the weekend. And yeah, we were in Boston for the genetics, the American Society of Human Genetics conference, their annual conference that was in Boston, as I mentioned before. And so, yeah, Marco, if you want to, how did it go for you? I haven't really talked to you since we got back. Like
Yeah.
it wasn't too much. We were both pretty busy. So,
Yeah.
how did your presentation day go? Were you able to go to any cool
Sessions.
sessions and stuff
Yeah.
like that?
Yeah. 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 Well, first of all, Boston is a beautiful city.
Yeah, it is really
Like
awesome.
I know, like, you remember we were talking to the Uber driver. He was kind of sad that it was kind of like drizzling for
Yeah.
3 days and all that. But I mean, compared to the climate that we have here, that was kind of like nice,
Yeah.
fresh. But in terms of the conference, it was very interesting. I had the chance to. This is the second time I attend, and I think you as well, right? Yeah, you were there last year too.
Mm-hmm.
But yeah, it was definitely, obviously same scope in terms of the field, right? It's genetics, obviously, but it was different in the sense like, the sessions that I attended were a little bit different. I got to go to a few sessions that were more like statistical genetics focused.
Mm-hmm.
Those were tough to chew, really.
Yeah.
Like, statistical genetics is a hard, for me at least, it's a hard field, but it's also very interesting how they can determine different types of things. So a lot of people were doing work on Alzheimer's disease and Parkinson's, and they were just basically sharing their statistical models to determine the importance of specific genes that
Mm-hmm.
might be involved with the development of these diseases. Some people also had some knockouts, mice, where they also investigated similar diseases, not necessarily Alzheimer's and Parkinson's per se. They were a little bit less popular diseases, but still on the realm of neurodegenerative disorders.
Hmm.
So yeah, that was pretty interesting as well. I also attended a few of multi-omics sessions, and those were also different to what we're used to because, like us, we do metabolomics, proteomics, exposomics. But what they focus more on is the genomics, right? Obviously, looking at gene expressions and all
Mm-hmm.
that. A lot of like Manhattan plots, things like that too. Basically, identify genes that have a high kind of like expression under certain treatments, conditions. Uh, They were looking into that, and what else? Oh yeah, so the cool thing about the multi-omics um, sessions that I went is that they're developing like new ways to basically integrate the genomics with the proteomics.
Mm-hmm.
Um, and the integration of these two type of technologies is important because the genomics is going to tell you which genes are affected, and the proteomics is going to tell you biologically how is the cell, the tissue, or the
Mm-hmm.
organism being affected,
Yeah, how it's
right?
all responding.
Yeah, it's all the responses that take basically as a result of
Yeah, because
the
even if
genes
you,
that have been, yeah,
yeah, because even if you know what genes are, essentially activated or being,
disrupted.
yeah,
Hmm.
the proteomics can give you the, in terms of like expression levels, right? Like if you have more expression of the protein or less expression of the
Yeah, it will give
protein.
you biological relevance,
Yeah.
right? Like it will tell you like the bioactive mechanisms that will eventually result in a phenotype, right?
Mm-hmm.
Um, yeah, so that was interesting as well. Yeah, my posterization went well. I had good questions. Nothing too very challenging to be honest, but because my work it was a little bit more focused on developing an LCMS assay for doing basically gene environment interactions.
Mm-hmm.
Um, so a lot of people were really like, oh wow, this assay can detect all these toxins, and that's really cool. But my work itself was not very heavy on the genetics part
Yeah.
because my work is still like a foundation to eventually do this gene
Like
environment
I,
interaction.
yeah, I was gonna say, like I asked earlier, right? Like, hey, investigating the genes that are,
Yeah,
that are involved or maybe protective, right?
yeah,
Like somebody who's got the aflatoxin and is sick versus somebody who's got aflatoxin levels that are similar and isn't sick. So,
yeah. Yeah. So yeah, it was pretty good experience, and the city was awesome. Very different to what we have down here.
yeah, for sure.
But yeah, it was a good experience. Yeah.
Yeah, and for me, I had it was really busy, good experience, stopping by the vendors and doing all the different things. But I have to say, because you were gone by Friday, and so you didn't see
Mhm.
the conference, it was like day and night, honestly. So like Thursday, you walked into the convention center, and it was just like noise and everybody, and it was just like it was like a beehive, basically, like
Mhm.
just busy. Everybody's moving around, and Friday just felt so dead. It was like going to you know um,
Empty.
yeah, yeah. I almost felt like it was like going to church. It was just like everybody's quiet, not not
Yeah.
just, and there was still a good amount of people there, but it was just like so quiet and chill. It was like a whole different vibe on Friday.
Mm.
And yeah, I still had a good amount of people swing by my poster as well. People were more interested in learning about the lab possums themselves because had never heard of lab
Yeah.
possums. So they're like, lab possums, what is that? Like, what makes them unique in terms of versus the mouse or rat models, animal models. And but it was funny because I would start talking to people about my project, and then I would mention like, hey, this is like gene environment interaction kind of research, and I'd mention how we tried something similar with the aflatoxin,
Mm.
but that the pups were really,
Surviving.
yeah, weren't handling it too well. And I met one young lady when I mentioned aflatoxin, her eyes like lit up, and she's like, "Oh, I know all about aflatoxin." And I can't remember exactly why she knew about it or what the case was, but I know quite a bit about aflatoxin in terms of just like um, not so much like the science and the mechanisms and the adducts and the metabolites and all these different things. What I know about it is just like more the regulatory, like it's in our food system, exposures,
Hmm.
um, I guess, the way it induces harm to whatever organism. And so, yeah, I kind of wish now, I wish we can go back in time, and I wish you could have gone with me to Houston whenever I was like on that whole journey of like learning about aflatoxin and how it's regulated and how the state of
Yeah,
Texas
that
does
would have
everything.
been very useful for me. Yeah.
Yeah. So, yeah, it's pretty cool to kind of get, now that I do my air pollution component of air pollution and have a little bit of knowledge about the aflatoxin as well. I feel like it gives me kind of a better understanding in terms of like studying gene environment interaction in terms of exposomics, right? Because I understand a little bit. Obviously, I understand more about my benzoate pyrene and air pollution, but I also have, and then of course in conversations with you, I understand more about aflatoxin and everything involved with that. So yeah, we have about 5 minutes left. So is there anything you want to share in terms of, um, you know, words of wisdom for undergrads? Maybe the undergrads you're teaching now, or no, but
Yeah, there's some good kids that I have in class, but no, I mean, I think
or maybe even just like your hopes for the future in terms of like, obviously we're doing this work, learning about exposomics because we want to help people live healthier, better lives. So, and obviously everything we focus on in our department is involving disease
yeah,
that plague the valley.
hmm, yeah.
So, anything you want to share, whether it's your hopes or
Yeah.
any advice.
No, I mean, kind of like I'm a big advocate for research,
Mm-hmm.
any type of research really, but obviously my experience comes to biomedical research, including this genetic stuff that we're working on right now, and that we're trying to become experts on, right? But um, basically say mention to undergrads or those that might not have a very good idea of what they want to do, or those that have a good idea but maybe they might think about a plan B or even a plan C on what they want to do, to try to be exposed to the scientific research that we do at the university, whether it's with our department or other departments, right? Because it's such a valuable skill to have, because
Mm-hmm.
it doesn't only, it's not about just following instructions on a protocol, but it's also about troubleshooting, critical thinking,
Yeah.
making decisions that will advance your work, and also being able to collect data efficiently, and also how to interpret that data, right? And all these skills that research can give you are very valuable skills in any field in the future, whether you
Mm-hmm.
decide to stay in research or not. So I always, since I was teaching in high school and with my undergrads, I always mention it like, hey, if you're interested, just give it a shot, right? So yeah, that would be kind of like my advice for everyone.
Yeah, I think that's a good point, because a lot of people kind of get, through grade school and maybe even before or in grade school and into their, college careers. Some people are really opposed to learning math because it's hard. And it's hard for, I'd say it's hard for 90% of the population. Some people are naturally kind of good at it and kind of grasp it faster than others. But it's just like anything, it takes a lot of work to build those skills and to gain those techniques. But I think it's so powerful because it teaches you to think, like you said, like think critically. Like, okay, you have this, and with math, there's so many ways to solve a problem. And so there's more efficient ways to go about it, and there's less efficient ways to go about it.
Yeah.
And it kind of trains your brain, and it's the same thing as you if you go for engineering or for chemistries or like any of the sciences, because you've got to train your brain to think in a completely different way that is really non-intuitive, right? Because like chemistry, for example, I feel like a lot of people kind of struggle with chemistry because you're learning about things you're never going to see. You're never going to see in terms of like the atoms themselves, right? Like you might have a pure compound and it's a white powder or, like a yellow powder or whatever the case is. And it might be a pure compound of whatever, molecule. Um, but you're never going to physically see the molecules themselves. And I think that's why I loved organic chemistry, was because they give you two molecules and they're supposed to react with each other, and you have to understand the mechanisms and the rules, and try to anticipate what the product is going to be and any byproducts.
Hmm.
And so it's like, man, it was so cool, but it's so hard to train your brain to start, thinking that way in terms of like, man, what I used to do was like I would try to like astral project myself. Like, okay, if this molecule was right here in front of me and it was 20 feet big, 20 feet tall, like I could like literally just kind of like imagine myself kind of like floating around it and understanding like, okay, I don't remember exactly like what was it called? Like the stereochemistry in terms of like R and S and certain rotations and the way you should orient the molecule based on what's attached to the molecule. So what I would try to do is just like imagine myself in front of a giant molecule that I can kind of float around and kind of do chemistry with. And then with engineering, it was kind of the same thing in terms of just like training your brain to think like an engineer, which is not an easy thing to do. And it just like anything though, like I mentioned, it just takes a lot of work and time, And what I used to tell people was like, man, when we were kids, tying our shoes was hard, right? But now it's like, you do it over years, yeah, and it's just it comes with training and practice and repetition, and I think that's why math is really, I think, important because it just takes repetition and practicing problems of all kinds, and that goes for anything else too. So yeah, a couple minutes left. Any other words, Marco? Anything else you want to share?
No, well, just no, just in addition to math, I think other thing that I taught to my undergrads is reading and writing. I think
Mm-hmm.
those are two really special things that not a lot of people in our community do.
Mm-hmm.
And I say it based on my own experience with the people I grew up with, the people around me. Yeah, there was obviously people that would do it, but I'm talking about the larger part wouldn't, right?
Mm-hmm.
They would just do what was necessary, but not have an interest on continue doing it as kind of like a hobby or something that you do at home
Yeah.
to spend the time, right? But yeah, if I were to talk to the younger me, maybe from middle school or early high school, I would be like, hey, I think you should read and write a little more.
Yeah, for
Yeah,
sure.
that make things easier now,
Mm-hmm.
and because people are exposed to reading, they're able to think critically
Mm-hmm.
better, right?
Mm-hmm.
Because they have all these ideas coming out from the stuff that they read. They have like all this plasticity in their brain to be able to remember things, to be able to think critically overall.
Yeah.
And writing is kind of like the product of all this reading that people can do, so
Mm-hmm.
they can make better sentence structure and all that. And
Yeah, yeah.
that's also very useful for any field that you.
Yeah, no doubt. It's like reading comprehension, right? Like it's one thing to just read, but it's also another thing to read and understand what is being conveyed. And so, yeah, that's a really good point. And for me personally, one of the greatest books I've ever read, um, it's called The Story Grid, and it's called The Story Grid. And basically, this editor, he's like a really, I don't know if he's famous, but he's like probably one of the top editors around, I don't know, in the country, in the world, or whatever. But he spent over 10 years writing this book called The Story Grid about his editing process and what he thinks about and the different genres of the different types of stories. And basically, it all boils down to kind of like the same elements. And after reading that book, I was able to really understand better like story structure and storylines. And so now I can watch a movie or read a book and I basically kind of know what's going to happen. Like I don't know exactly what's going to happen in terms of
You know what to expect.
yeah. And so a quick example is I was watching a documentary and and in the documentary, the person that it was about, I think it was their father. Their father had died, and it was like a very tragic part of the story, like shedding a tear, like fighting back tears, and it was very sad. And I paused it because I was like, man, I'm going to pause this documentary, and I know we're going to be at the halfway point of the documentary. And sure enough, I paused it and it was halfway through. And I was like, wow, I knew that because of that story grid. Because, all, they kind of call it the hero's journey, right? So, like, you have somebody who grows up down, broken, parent, and that's like a big part of like a lot of Disney stories, right? At the beginning of Disney movies, the parents are dead, or some tragic, Bambi's mom gets shot. It always starts with tragedy and then it's the hero's journey of like growing through that hardship and enduring hard times, and then about halfway through something drastic happens, whether it's good or bad, and then it just helps develop the character more and more and more.
And that's why a lot of people try to kind of like. That's what they like the movies because they kind of like portray that story to
Mm-hmm.
themselves.
Mm-hmm.
They think back like, oh, I also went through hardship, right? And we all of us do,
Yeah.
one way or another. All of
Mm-hmm.
us do, but that's just life.
Yeah.
At
Yeah,
the end of the day,
exactly.
that's just life, and we
Yeah,
gotta
that's one
be.
thing I always mention on the show. You know, it's important not to get too down with the lows or too high with the highs. You know, you gotta try to stay even keel because bad stuff happens to everybody. And yeah, I mean, it's okay to grieve for a while and try to um, I guess in a not so sensitive way is get over it. Get over whatever happened, whether it's a breakup with your loved one or your significant other or a passing of a family member or whatever. But I mean, that's unfortunately life. Life is going to hit you hard, and one week it's going to be bad, and bad things are going to happen. But if you don't stay down in terms of like your attitude and your mentality, something good's going to happen, right? If you just keep working hard, you're going to get that job you were wanting for. You're going to get that degree you were, working so hard for. And then, you're going to get that promotion or whatever the case is. And after that, life is going to come back and slap you up again, and then it's going to bring you back down, and then something good's going to happen. Yeah, for sure. Well, I guess that's everything. So thank you so much, Marco, for coming on the show. I
Thank
appreciate
you.
you having you on and updating us a bit on your project and everything you've worked on over the last year. And I know how hard you've been working because I see it all the time. And
Thank you.
yeah, of course.
My
So
pleasure.
all right, everyone. Well, thanks again, and stay tuned for next week. I'm planning on having as next week's guest, if you're a regular listener, Elvia Gibbs, a breast cancer survivor. She's been on the show twice already, once in the spring earlier this year, and then about a year ago in the fall of 24. So yeah, looking forward to and actually gonna give a shout out to her right now because I was hoping to have her on today, but she's heading over to MD Anderson for some follow ups or checkups. So really looking forward to having her on next week to talk about everything she's got going on and how everything went today. So hope you're doing well, Elvia, and looking forward to seeing you next week. So that's all I got, everyone. DJ Kalicha Kid here to remind you to stay curious, stay healthy, and let's thrive together, RGV.